Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving headfirst into a truly mind-bending achievement. A Lambda calculus interpreter squeezed into a mere 383 bytes. Incredible.
Whoa, 383 bytes? That's smaller than most Hello World programs in other languages, right? What's the catch? Is it, incredibly limited?
Well, there are a few limitations. It's a binary Lambda calculus implementation, meaning programs are encoded as sequences of zeros and ones, and the 383-byte version has a limited displacement, restricting program size, but it still manages garbage collection, lazy lists, and tail recursion, all in under 400 bytes. Amazing!
Lazy lists? In 383 bytes? That's insane. So how does it even work? Is it some kind of crazy bit manipulation trickery?
Exactly. It reads the program and input from stdin, one bit at a time. The encoding is straightforward. 00 for abstraction, 01 for application, and 10 for variables using a variable length encoding. The interpreter uses a Church-Krivine-Tromp virtual machine. It's a beautiful piece of engineering.
A Church-Krivine-Tromp VM. I've heard whispers of that. So what kind of programs can you actually run on this tiny thing?
Surprisingly powerful ones. The article shows examples like an identity function, a bit inverter using the Y Combinator, and even a Hilbert space-filling curve generator. Now, they even have a metacircular evaluator written in BLC itself. Only 232 bits. That's meta.
A metacircular evaluator in 232 bits? I'm speechless. That's almost philosophical. What about practical applications? Is this just a cool hack, or does it have any real-world uses?
It's definitely cool, but there are potential uses. Imagine self-extracting archives where the interpreter is embedded in the compressed file itself, or embedded microprocessors, where code size is paramount. The author even suggests potential applications in compression formats, using Lambda expressions to encode and generate data. It opens up some interesting possibilities.
I see. So it's not just a theoretical exercise, it's a practical demonstration of how far you can push the boundaries of code density. But I'm a little skeptical about the claim that this tiny VM has capabilities the JVM lacks. Isn't that a bit of a stretch?
You're right to be skeptical. It's a bold claim, and while the VM is incredibly compact and has some unique features due to its design, claiming it surpasses the JVM in capabilities is, a bit of an overstatement. The JVM has decades of development and a vast ecosystem behind it. But the sheer ingenuity of this 383-byte implementation is still remarkable.
Absolutely. It's a testament to clever programming and a deep understanding of Lambda calculus. This is fascinating stuff. Thanks for breaking it down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.